We will return in this video to the example that we talked about in the previous one. In the previous one, we took a very particular normal distribution. So we talked about a random continuous variable with mean is equal to 0 here, mu is equal to 0, and sigma 2, the standard deviation, or the variance is equal to 1. Well, the standard deviation will be equal to 1 as well. But this very particular choice for normal distribution has a name, and the name for this one is a standard normal distribution. So we say that the random continuous variable has a standard normal distribution, or is a standard normal distribution. So the probability density function for z, the random continuous variable, is given by phi, and phi is given by this expression. Don't worry about this expression, it's not in your curriculum, it's just an extended part for you to see what is the expression of that function. And this is the graph for the standard normal distribution. As you can see here, the mean is equal to 0, and you have the same percentages that we've talked about previously. So the axis of symmetry is x is equal to 0, the y axis, and we have the variance is equal to standard deviation, which is equal to 1. And when we are talking about values plus or minus 1, plus or minus 2, and plus or minus 3, those represent values that are 1 to 3 standard deviation above or below the mean. And another thing, any value that is less than 0 represents the value that is less than the mean, since the mean is equal to 0. Any value that is more than 0 represents a value greater than the mean. And a very important remark here, that for z more than 3 and z is less than -3, then the probability, or phi z, is equal to very close to 0. As you can see here from the graph, it's very close to 0, the graph here. So this is why we have this remark. Sometimes it's important for you to know this, because sometimes in exercises they will ask you, can you say that this event is likely to happen or not likely to happen? So you need to remember this remark. Now, if we draw a line, a vertical line like that, in any different position for this graph, it will divide the graph into two parts. The first part is where we are looking for the values of big Z less than little z. Imagine that little z is equal to 2. So the probability that z is less than little z, it will be the area under this graph starting from 2 here. And the probability that z is more than little z, it will be this small area here. Okay. So to make it less complicated for us when we are talking about the probability of z less than c, we will denote it by phi of z. Okay, and phi is that function that we've talked about. And to get these probabilities, we are going to use a tables that are showing the values for phi. Those tables are pre-made by scientists, so don't worry about calculating the area of that or the integral of that bar function. So you may look at your books, page 222. This is what you will see. So as you can see here, you have a lot of values, and the values vary from 0 to 2.9 for the value of z. So why we have the values between 0 and 2.9? As you can see here, I told you here in this remark, the values that are more than what is it? Values that are more than 3 or less than 3 are not likely to happen. So this is why we are focusing on that range of values. Okay, so although only 0 and positive values are showing in the table here, so I have values between 0 and 2.9. I can use the symmetry of the graph to get the values for negative z. Okay, and you will see later that we will use the inverse of phi to get the values of little z. It's possible to do that. Okay. So yeah, now a very important question is how to use that table and how to get the probabilities using that very big table. The values for z appear as four-figure numbers, okay, from 0 to 2.999 in the table. Now, the first and second figures of z are here, represented here in the left-hand column. The third and the fourth figures appear on the top row. So this is for the third figure and this is for the fourth figure. Now the numbers in the add column, we are talking about this one, for the fourth figure, indicate what we should add to the value of phi of z in the body of the table. So if I have 1, I need to consider these values to add. If I have 2 as fourth figure, I need to consider these values to add, and so on, so on. So yeah, it seems a little bit complicated, but with practice, we won't have problems with this. So let's take an example. The first example here, they told you to find phi 0.274. In other words, they are asking you to get the probability of big Z is less than 0.274. So we need to use a table. We need to follow these steps. The first step, we need to locate the first and second figures of little z. So as you can see here, the first figure is 0, the second figure is 2. So if we use the table here, it's located here. Now the second step, we need to locate the third figure. The third figure is 7 here. So the third figure should be located here in this row. So the third figure is here. Now I need to see what is the intersection between this row and that line. So this column and this line. So the intersection between these two is this value. So it's 0.6064. So now I have the value here, and that value tells me that it corresponds to phi of 0.27 here. Now, to carry on with this, let's clear all of it. Now, to carry on with this, I need to follow the last step. So the last step, I need to go to the fourth figure. The fourth figure is 4 here. And I need to focus on the intersection of this line, this one, this column, and the same line where we found the first value. So as you can see here, it's 15. Then I need to add 15 to the last two figures for this value here. It's 0.6064. So if I will apply this, I will get this result. So let's apply this. So phi of 0.274 is equal to the sum of these two, and the result will be 0.6079. Now let's take another example. Let's say that Z has a normal distribution, normal standard distribution. Okay, and they ask you to get the probability of Z is less than 1.23 and the probability that Z is more than 1.23. Now we know that the probability of Z less than 1.23 is equal to phi of 1.23, and this represents the area under the graph where these values are less than 1.23. So if we will use the table, it will give you that it's 0.8907. Now, if I would like to get the probability of Z more than 1.23, as you can see here, it's just the complementary part here. So this part is exactly this part. So since I know the probability of this part, and I know that the probability under the whole graph is equal to 1, so I just need to minus this area here from 1. So to get the probability of Z more than 1.23, I need to minus the probability of Z is less than 1.23 from 1. And the result will be 0.1093. So let's take another example. And Z is standard normal distribution, and they ask you to find the probability that Z is between 0.4 and 1.7, corrected to 3 decimal places. Now the probability of Z is between 0.4 and 1.7 is equal to the difference of phi of 1.7 and phi 0.4, because it's the difference between the two areas. So the first area is this one. The first area of phi 1.7 is the whole area here. Yeah. And the area for, let's take another color. The area for phi, or the area when the Z or big Z is less than 0.4, is only this area. So it's like I need to minus this area from the first area that I shaded with red. So if I do that, and I need to use the table to get the value of this one, okay, the way that I showed you. And if I will apply it directly, I will get 0.300. Here I add the 2 zeros because they ask you to write your answer corrected 3 decimal places. If you don't write it this way, they will count it wrong for you. So please be careful when you are rounding numbers. Okay, so far in examples, we only saw this type of cases when little z is equal to a positive number. But when it's equal to a negative number, it's not a big deal, because I need to make sure to remember that the area here, will be equal to the area when, for example, if I had A here, let me draw it for you. If I had A here, so that is, well, it's not exactly A. If it's A here, and let's imagine this one is equal to this one, the distances. So the area, this area here, will be equal to the area from the other side because of the symmetry of the graph. Okay, I know it's not clear enough, but I think you got the idea. So using the symmetry here, I have that the probability of z is more than negative a is equal to the probability of z less than a, which is equal to phi a here. And the probability of z is less than negative a, which is this little area, will be equal to 1 minus the probability of z is less than a, which is equal to this one. Look, this area here. So having a little z with negative sign, it's not a big deal here. So, for example, knowing the information that phi of 0.11 is equal to 0.5438 actually tells us 4 probabilities. The first one, I have the probability of z less than 0.11 will tell me that the probability of z is more than negative 0.11 is equal to the same probability. They are equal because of this rule here. And the probability of z is more than 0.11 is equal to the probability of z is less than negative 0.11 because of symmetry, and it's equal to 1 minus the probability of z is equal to 11, which is equal to this one. So the result will be 0.4562. So keep in mind, when you are looking for probability of z more than something, it's always equal to 1 minus the probability of z less than that something. Okay, let's take an example. Here z is a standard normal distribution, and they ask you to find the probability of z between -1 and 2.115. So a quick tip for you, please always draw a graph for you. Sketch it. A little sketch, it will help you a lot to get the probabilities correctly. Now, the probability of z between -1 and 2.115 is equal to the probability of z less than 2.115, which is this area, the whole thing here, minus the probability of z is less than -1. So this is the area that I need to cut. But the probability of z less than -1, well, the probability of z less than 2.115, this I will get using the table. Okay, it's phi to 115. Just go to the table, apply the steps, and you will get the value. But for this one, p, the probability of z less than -1, I will apply what we saw in the previous section here. So it will be phi of -1. So phi of -1 is equal to 1 minus phi 1, as we saw in the formula. Then the probability of these between -1 and 2.115 is the difference of the two probabilities. So it will be phi 2.115 minus, between brackets, 1 minus phi 1, which is equal to phi of 2.115 plus phi 1 minus 1. Okay, so the final result is equal to 0.824. So always keep in mind to use this kind of formulas